Hello, everybody. Today is August 13th, 2020, and this is the OLM Working Group. Looking at the agenda today, we were going to be discussing an enhancement that we requested from the previous OLM Working Group. We're going to discuss a new operator plugin for kubectl that was shared on the operator mailing list. We are going to discuss the OLM's 1.0 status, which I believe is related to upstream downstream splits. And we are going to discuss how OLM/OPM versioning and whether or not it is supported by OCP 4.6. And it looks like we have an issue related to channel override support status. So kicking things off, Nick, do you want to go over the status of the enhancement for issue 1523?
Yeah, sure thing. So let me just share my screen real quick. Great. So this issue is about bundles having a combined set of manifests larger than the etcd storage limit, not being able to be unpacked properly on a Kubernetes cluster, thus not being able to be used. So we had a meeting last week to sort of prime the enhancement, get a couple ideas together. Thank you to everybody who was on that call. So if you want to see that, I believe this primer doc is in the enhancement, and the recording is attached from that meeting, so you can kind of see our initial thoughts going through. There is now a draft PR up that aggregates some of probably the most plausible solutions for the short term, but it is really important that we get feedback on this, and this is against the operator frameworks enhancement repo. So we need to propose or flesh out this strategy for handling these big bundles. And it kind of boiled down to 4 main categories of solution. And if nobody has questions about the problem itself, I can just go over a few of these, and then we can move on to the next thing. So if you have any questions,
it might be valuable just to do like a 500-foot view of what the problem is.
Yeah. So to give some background here, there's also some few things scattered throughout the proposal that help new folks understand this, but basically there's a requirement in OpenShift that we, or for OLM to run on the OpenShift platform, that we use pod specs to pull images rather than pulling them directly. And what this means is that it's a little bit more expensive to pull bundle images into the cluster. And so we need a way to stage the content so that we don't have to keep running these pods over and over again to get the data out. And the immediate way to do that was to just store all the manifests in a config map when we impact them this way. Now, the problem with that right now is that when we stage the operator bundles, there's a one-on-one relationship between a bundle and a config map. So the limit to this is essentially the limit for a value in etcd for an API resource in Kube. And that's around 1 megabyte. So anytime you have near 1 megabyte of manifests in your bundle, OLM is unable to unpack that, even if the individual manifests are not up to that limit.
So just a quick question. So the bundle image can store, you know, all sorts of stuff. Some of it is recognized and some of that wouldn't be recognized. So is it just blindly all the data that would be in the bundle image would be included, like all manifests that wouldn't normally be exposed or recognized by OLM? Or do you just suck in the ones that the OLM is aware of?
So right now there is currently only one active bundle spec, and that bundle spec has references to a manifest directory, and that manifest directory has strictly kubectleable YAML in it.
Right. So what I'm saying is if I had custom CR manifests in there, they would be included?
Yes.
Okay.
And I mean, like, we can, right now, OLM will only apply a certain set of them at runtime that it kind of has an allow list for. But as we open that up, OLM will be able to apply more and more, but the bundle side of things isn't constricted in that regard. So I think there's a concise user story in here that kind of gives the formal language for it, which is like, as an operator author, I want OLM to be capable of unpacking and installing a bundle that contains an arbitrary number of resource manifests, each no larger than the limit for an individual API resource on a target cluster, so that the size of what I can package as an operator is no more limited than that target cluster. And that's just a fancy way of saying, look, if I can apply my resources directly to this cluster, I should be able to put them in a bundle and OLM can do it, as long as individual resources will fit on my cluster. So are there any questions about that problem beyond this? Okay, I'll take that as a no, and I will just move on to some of the options. So I kind of, these are the most, I think, feasible things that we can do right now. And they can be abstracted under the hood away from OLM, but one of them is, or I should say the first one is like a chunked bundle sharding. So when we go to stage these images, we chop up all the manifests into chunks that get stored into respective config maps, and each chunk is sized to fit within a config map. And so we can figure out some, chunking algorithm for this to determine like the best fit or the next best fit on a cluster, because that etcd key or value size could change depending on how your cluster is configured. So you may be able to get away with larger chunks. And here I just, added some info that like we could control this with like a flag on the catalog operator, or we can potentially probe different sizes of config map to see what doesn't return an error and do some sort of binary search over those things to figure it out. I couldn't really find anything nice that can tell us directly from an API level what the maximum value of an API resource is, but if there is not one, we could do some probing like that. An even simpler thing to do is a non-chunked sharding with compression. So we can use something like gzip to still do a one-to-one mapping of manifest to config map. This still has limitations, but depending on the compression ratio of that compression algorithm, we could potentially fit the max size resource into a config map. So that's a little simpler. We don't have to keep track of these other things. C was kind of interesting. So instead of caching these things in config maps, we can or in API resources at all, we can turn around and say, let's use a file server. So we will start with a pod. It'll have some expiration every time we're looking for something from this bundle. We check to see if that pod exists, we create it, and then that'll serve the manifest directly from some endpoint that we can query and apply from. And then the last option, which is the most user-facing, is to add a new API that describes a bundle and describes how bundles will be pulled. So it has a specification that you drop in a reference to, let's say, a bundle image. That gives you some stats on what's going on with the pull and the unpack and everything. And it'll have another sub-resource /manifest, which will actually give you a list of the unpacked manifests. And so because we're using sub-resources, this needs to be served by an extension API server. And then we can do some cool stuff to get storage, and we can actually use some of the stuff that we talked about in like options A and B to provide a portable backend for that. So we can implement that store interface and then drop the resources across our config maps. So these are some of the top ones. They're not all of the things that we discussed there.
So option D, the bundle API. So that's not basically converting a config map to a CR. You're basically providing an interface to be able to abstract away from the implementation.
Yes, and I'm saying that we can implement the storage as something like option A under the
right.
So
it's
like
kind
a
of
key
like
value server.
I would say it's almost kind of orthogonal to the implementation, right? It's just a nicer API to abstract it out. As far as A, B, and C goes, I think B is bad because it only pushes the problem out a little bit. I like A just because that's my background. I'm an old sharding guy from other products, so that's like the way that scales like infinitely, and it seems a little bit more natural to me, I guess, and more portable.
Yeah, I think it's really important to. So, do we want to discuss the enhancement here, or should we make sure to actually have the conversation on the enhancement PR itself?
I would opt for having it on the enhancement itself. I just wanted to walk through a couple of the options today, and I think we have enough stuff to get through that we don't want to be hung up kind of doing this, because there's a bunch of ways to do this,
Right.
and we're just trying to pick the best one.
Yeah. So, Chris, we definitely want your feedback, but could we deliver it via the?
Yeah, absolutely.
Awesome. Great. Okay. So, big goal today is to get through the whole meeting. So, we're going to move on to the next item on the agenda, and sorry, I just lost the. About the new. Okay, here we go. The new operator plugin for kubectl announced. Chris, I know that you created this bullet point or a topic on the agenda. We do have Joe Lanford on the call, so he can speak to it if you have any questions that you want to direct towards him. But first, could you give us a little more information about what you want to discuss regarding the plugin?
Yeah. So this ended up in my inbox this morning, so it was cool. So I went ahead and looked at it. And so I looked at the source code of it, and I played with it just for a few minutes. And I guess I just wanted a little bit of background on what drove, what problems is it trying to solve, and what is the strategy behind it. Because I looked at the source code, and it looks like it actually does a lot of the stuff that OPM does. OPM seems to be, a little bit more of a build tool, but it's also a runtime tool. And this is kind of an operator tool, but it also does some of the stuff that OPM does. So I'm kind of curious to see what the rationale is and if we should be seriously looking at that for our pipelines.
Yeah, so I'm Joe Lanford. I'm the team lead of the operator SDK. So I kind of did this kind of working on the side during some Red Hat hack days, and the impetus was, at least for me, and maybe some of the OLM guys can tell me if I've duplicated some stuff, but at least for me, working with the operator SDK and seeing operator developers try to go from, here's my operator source code, I've got my bundle built, now how do I run this thing in a cluster with OLM? It seemed like there was this missing set of tools that could make this a lot easier. So at least my impression was that, like, okay, I built my bundle, I can use OPM to build an index. And then I need to get that index running in the cluster. So I need to create a catalog source. I didn't know of any tools that created catalog sources for you in the cluster on the command line. Maybe that exists. So there's like the kubectl operator catalog add remove list feature that you just basically give it an index image and it will set up a catalog with that index image for you. And then OLM then has a lot of functionality built in that you can say, like, okay, we'll now list the available operators, and it uses the package manifest API to basically just print a nice big table of all the operators. It's kind of just a wrapper around kubectl get package manifests, all kind of bundled into this one plugin, at least for that part of the command. And then from there, then you can actually do the operator install, and there's a bunch of logic in the installation command that kind of helps you out. So with OLM, you've got to create an operator group, or you've got to install your operator in a namespace that already has an operator group. And you have to kind of understand the concepts behind operator groups when you're doing that, right? So with kubectl operator plugin, you can just say kubectl operator install operator name and watch these namespaces. And what it'll do is it'll say, like, okay, well, let me see if if the operator that you want to install even supports the mode that would be necessary to watch those namespaces. So it's going through the underlying packages. If it doesn't, it'll error out and say, like, sorry, like that operator doesn't support the mode that's required to watch those namespaces. But then it'll also like check to see if the namespace that you're trying to install the operator in already has an operator group. And if it does, then it'll also check to see if the namespaces that you're trying to watch are compatible with the operator group that's already there. And if it doesn't, then it'll error out. So there's like all these kind of things that help you not necessarily have to understand all of the underlying concepts to get the thing installed, right?
Yeah, so from that perspective, it sounds like what you've done is you've taken a lot of the stuff that the console does and you've put it in the command line.
Right.
So I think that's super handy because people don't get what operator groups even are. And a lot of the stuff that the console does for you, they don't realize they need to do by hand. And so that's really handy.
Yeah, and I will say that I didn't take a whole lot of input from the OLM team. So I was just talking with Evan this morning. So this is like very new. I think it's probably like 3 weeks old. I hacked it up almost in like a couple of days based on some of the other things we're working on the SDK team. So this is, I wouldn't necessarily tell you like, oh, go and put this in your production pipelines yet. Like I would probably say, like, let's get more eyes on this for a little bit to make sure that it does all the right things and makes all the right assumptions and doesn't have like really stupid bugs in it. But at least in my testing, and here's the other thing, there's no unit tests, there's no end-to-end tests. It's all just like, I've been manually testing this and it seems to work on the happy path. It's all very early. So at least I am, and I'm sure all of us are definitely interested in getting feedback and getting people using it and seeing how it works. So last week, I put this in the email this morning, but it was just added to the kubectl crew plugin index last Friday. So now it's easy to install. So all of the kind of the little bits to make this easy to use are there. And it's just a matter now of getting some feedback, fixing any of the rough edges that exist, maybe tweaking how things work here and there, adding some other commands that might exist. And then I've started adding some issues into the kubectl operator repo that talk about some of the things that would be nicer to be able to do that require potentially some OLM changes, or at least me to have a better understanding of how OLM might help me solve those things. So there's definitely some improvements that could be made with that kind of stuff as well. So yeah, I would say don't use it yet in production. Definitely try it out. Let us know how it works. We're definitely interested in getting some feedback there. And yeah, and the intent was basically, right now, the only easy way to do this is the console, but not everyone has the console. Like OLM should be usable without the console. So let's make it easy in other ways as well.
So what was your drive to build this? Is it because you're personally frustrated with dealing with all of this boilerplate stuff you had to do, or did you actually have a customer requirement?
Pretty much personal frustration. So like as in an operator SDK development environment, I can't remember the last time I've been running something with OpenShift. So I don't have the console. And I think there's maybe a good chunk of operator SDK users that fit that mold. So for me, it was just like, how do I make it easy to, after I run the make bundle command in operator SDK, like how can I get this easily and quickly running in a cluster that has an OLM installed in it? So yeah, it was personal frustration and probably a little bit of feedback that I had seen others say, like, oh, like we have some internal Ansible operator developers who have told me, like, I've tried this, build the operator, create a bundle or the old package manifest format. And he said, like, I gave up, 5 different times. And now that I've seen this kubectl operator, like I get it now, I see how it all works. And this is the first time I've been able to go like soup to nuts from source code all the way to running in the cluster without having to touch the console.
So are you utilizing any of the operator registry APIs? I noticed using like the containerd, standing up like a temporary registry to do a bunch of build stuff. Like for example, if you're going to add a bundle to an existing index, right? I noticed you're doing a bunch of stuff inside a pod using containerd. So all of the things that, so manipulating the actual bundle images and stuff, are you using OPM directly or using the libraries or?
It's libraries, yeah, it's libraries. So it's the operator registry libraries, yeah. The one thing that's a little bit unique about what's going on with, there's this mode of catalog add that we're developing as part of the SDK, but also can apply here, where you can have a bundle and you don't have to have an index like in a registry to actually be able to run the bundle. So the way, I don't know if you saw this part of the code, but basically the way it works is there's this base image called upstream OPM builder that exists that has the OPM binary in it. So what we can do is basically dynamically spin up an upstream OPM builder pod, change the entry point to call OPM index add and then OPM registry serve like back to back. And then like we've basically got this ephemeral index running in the cluster that has our one bundle in it. And we can install the operator from there. So there's like this little shortcut, which we really needed on the operator SDK side to make it super easy for an operator SDK developer to be able to build their bundle and to then like immediately run that in the cluster without having to push an index image.
Your Achilles heel there is to make sure you're using the right upstream builder bundle, or the builder image. That's the thing that kept Evan up at night a couple weeks ago, because it pulls the wrong one potentially, because they're not always compatible.
Yeah, so if there's some improvements to make, the way that it works in the catalog add is that you have to give it the index image, even if it's the base one.
So you can use the OPM binary from whatever your base image is that you're going to add the bundle to.
As long as, so the way that right now it works, and again, this is very much like alpha-y, and it works because of how I know the underlying base images work, but right now, if you provide bundles, so there's a flag that you can pass to catalog add that's like inject bundles. If you provide some bundles there, right now it's making total assumptions about where the OPM binary is in the index image that you give to it. So if there's a better way of handling that, then maybe we should do that. Maybe we can just rely on the path I don't know, haven't gotten that far yet. The way that we're making use of this in Operator SDK, we have this run bundle subcommand that we're working on, is if you, in that case, like we're given a bundle image and we don't, in the index image that we want to inject into is an optional flag. So in that mode, if you don't give us the index image, we know the one we're going to use, and we know that it has the OPM binary at the location we expect. So in that mode, like that assumption holds. I think in the kubectl operator mode, maybe there's some things that we can improve in terms of how this bundle injection to create a dynamic index could work. And if we don't like that feature in kubectl operator, we could also just take it out if that makes people too confused. But I figured I'd add it since it's already code we wrote for Operator SDK and might help people, right? You don't have to do the extra step of building the index.
Yeah, I guess I always struggle. So my team has been struggling trying to figure out the personas really for Operator SDK, OPM, Operator Registry, and now this tool, and they all have different personas. So the Operator SDK is really in my opinion, is a developer tool, right? It's there to help the developer bootstrap. It's not designed to really use on the production server somehow.
Correct.
Right. So OPM is about building, images that are consumed by OLM. And then the registry is a component of that, which actually is the interface between the catalog and OLM. And then this is kind of a hybrid, which is kind of an operational / development tool, which kind of helps you do development and, be agile and that kind of stuff. And so I think that's how
I think I primarily see it as like a cluster admin tool, right? Like someone who's using the console to administer the cluster and decide which operators they want to be running and when to do an operator upgrade. Like, I think that's the primary persona for this. But of course, like all of those same functions are super helpful for the developer use cases as well, because the developer is going to be building new bundles and wanting to get those things running in a cluster to see if their bundle is valid and see if they can upgrade correctly and that kind of stuff. So I think that like the obvious persona is the same persona of anyone else using kubectl. And then there's a large class of users of kubectl for various reasons, right?
Yep.
So I would probably say it's like the same class of people who are using kubectl.
I also think, just to jump onto this, that this is really good feedback for things to improve in OLM as well going forward. So things like, we've had on our backlog for a while the ability to run a bundle directly, right? It would be nice if you could just do that instead of needing to go through all these hoops. This also sounds like maybe there's something for a feature for a catalog source where you just give us one or more bundle images and those get run directly. Or just give us a volume mount and we'll build a catalog out of whatever's in the volume, that kind of thing. So I think this is a really great way to find out and get feedback on these features before we commit to doing them and supporting them forever.
Totally. There's some other things in there that like become a little bit more obvious too. There's right now with subscriptions, it's possible to specify starting CSV, but it's not clear if you're sitting in a cluster which CSVs even exist in an index, because all you see is the head of each channel. So there's like this little funny heuristic right now that happens in kubectl operator that makes some assumptions and guesses about how to build a starting CSV string without actually knowing if that CSV even exists in the index. So I created an issue that we can, I'm sure, talk about to basically say, like, would it be possible for OLM to expose all possible CSVs for each package in the cluster? And then it'd be a lot easier then to, from a user perspective, be able to say, like, I want to install this version of the operator.
And then show the upgrade graph possibilities, which would be handy.
Yeah, both of those things are absolutely things we need to do. If we don't have issues for them, we should. So let's make sure we get those.
Yeah, the other kind of thing that's, as you mentioned that, Chris, about the upgrade graph thing, and Evan and OLM guys, correct me if I'm wrong here, but the way that upgrade works is it always upgrades to the latest version in the channel. Like, is there a way to like say like upgrade from this version to this next version, but then stop before you get to the final head version?
So there's no way to define that programmatically so that it all happens automatically. But what you can do is you can set install plan approval to manual, and then one by one step through until you get to the version you're on, and then just not apply the next install plan.
Got it. Okay. Which actually is how it works, kind of right now, anyway. So yeah, that's another thing we can look at improving. kubectl operator, when you do install, it does set it to manual, so that when you say install at this version, it installs at that version. It auto approves the first install plan for that version, and then from then on, like it's manual. And then you can run kubectl operator upgrade, and it'll do the upgrade. That's the part I'm not really sure how that works. I think it'll just do the very next install plan that's sitting there ready to go. Anyway, so lots of interesting, still very alpha-y things to work through and talk about here, but for my purposes at least, it's been super helpful to be able to like quickly run through like an example operator, run through the quick start, run make bundle, run bundle push, and then use the kubectl operator to quickly stand up a catalog or run the bundle directly, instead of having to deal with crafting YAML files and that kind of thing.
No, I think it's super helpful. I appreciate you putting that out, Joe. It really got me thinking about a couple things, and I understand a little bit more how OLM works just by looking at what you put together in there.
Yeah, that was definitely part of the thought process too. It's like I wasn't really totally, and this is me sitting on the team right next to OLM. Like I don't quite understand all of the different nuances of how everything interacts in OLM, and writing the code for this, I think, really helped me personally learn, how all of these things fit together. And kudos to the OLM team for, having all of this stuff working. Really, really cool.
Just one side question. So when I did a crew install of that thing, I noticed it enabled it for both OC and kube control. Is the crew plugin automatically set up to talk to both?
The way that it works is that, so OC is basically vendor's kubectl. So I'm guessing it has the plugin code in OC. And the way the plugin code works is that it just searches your path for binaries named a certain way. So if they start with kubectl dash like a name, so in this case, the binary name is kubectl dash operator. So both kubectl and OC are probably using the exact same code to search the path for anything that starts with kubectl dash, and that it turns into a plugin and makes it available to run.
Okay. All right. So the discovery mechanism's the same, and then the API is the same. It's basically the same plugin.
As far as I know, I tested it out really quickly with OC the other day just to see if it worked, and I was like, yep, it seems like it works. I don't know if there's any like weird nuances between the way that it invokes it or like anything like that. As far as I know, the version of kubectl that OC vendors, you're going to get the same behavior as what that version of kubectl gives you.
Yeah, I guess the only thing to think about is because you named it operator, so I'm not sure about the crew namespace and who owns that thing. I mean, does that want to be like operator framework operator or something like that? Just specific, because it's an OLM specific thing.
Yeah, there was actually some, if you go find the crew index PR that I created for the original one, there was actually a lot of debate about the name.
Yeah, I bet.
They were hesitant to let us choose the operator name because it's so generic. But since we recently were admitted into CNCF as the operator framework, and there's no other product out there in CNCF or otherwise that's like OLM, I don't think anyone really had an argument to make against us using that name. There was a suggestion to use the name OLM. I pushed back on that a little bit because at least in Operator SDK, we have an Operator SDK OLM install subcommand, and that installs OLM in your cluster. So I didn't want to have the same name and confuse people and think like, well, is this thing installing OLM or is it installing an operator? Like, what's going on? So I felt like, and I had Daniel Messer, our product manager, talk me through it too to see what his thought was. But we both felt like it flowed more obviously and a little bit easier to understand by using the operator name. And eventually they accepted it, so we're good there.
Yeah, I'm super stoked about that because you've just planted your flag there.
Right.
So now operators are OLM. So I think that's awesome.
That's right. and hopefully this is one of those tools that like gets more adoption out there. People see it in the index. They see operator. Oh, I know what an operator is. Oh, I need to install OLM. Oh, this is actually a lot easier than I thought it was. Like, this is pretty cool. So hopefully, like these types of things, making it out there, especially in the upstream repos, start to get that adoption rate up as well.
Agreed.
Yeah, awesome
I think
work,
this has been it's really great to see it. I really appreciate that you doing this, and I think it's been like a huge deficiency. There's this big void that's been waiting to be filled, and I really appreciate that you did that.
Absolutely, guys, no problem.
Okay.
I did have one follow-up question if we have a couple seconds. I think, Joe, you and Chris both mentioned something that I'm a little interested in, and I hope I don't sound too out of touch when I ask this question. But I'm curious why you would want to specify a starting CSV if you didn't already know that you needed to start at a particular CSV. Does that make sense?
No.
No, but yeah, can you explain that?
Right. So the idea of the starting CSV is that you need some particular older version of an operator and need to update to whatever the latest one is in order to go walk through some migration or something like that you'd pick up on the update path. But if you don't know that you need that particular thing, you would just not specify a starting CSV, right?
Yeah, that's optional, right? I hope.
Yeah.
It is. Yeah. In kubectl, it's optional as well. So Evan, I think the problem I was trying to solve is, and maybe this is just invalid, so tell me if it is, but like the way that you invoke operator install right now is you say kubectl operator install package name. So you type out, etcd or Prometheus or something like that. And then in an earlier revision, if you go back and look through the commits, an earlier revision, there was like a -- starting CSV flag. And you would then basically have to retype like etcd.v, blah, blah, blah. And it was like a little bit of a handful to type the same thing twice. So the way it works right now is you just type in the version number, which I realize now I've seen some of the operators that are in the community operators repo where it's not quite like there's more to it than just a version number potentially. Like the etcd operator has different channels with different names of CSVs so it gets a little funny, right? Like the package name doesn't always match the CSV format. So there's little things like that right now that make the kubectl operator version guessing like error prone potentially. But the thought process and the use case that I had was, in most cases, maybe I know the version number of the operator I want to install. So let me just type -- version equals this, and we'll install that version of it. But maybe that doesn't work in all cases.
I got you. So it's about, you need a particular operator version, but you may not know what the name of it is. That's kind of the idea.
Yes, I think that's fair. So Kevin just put a comment about, what was that, Kevin? Package version, yeah.
Yeah, is that right? Like the description already kind of has most of this anyway. The fact that you need to specify like the metadata name of the cube cuddleable object called CSV is almost like an artifact of how things worked in the first place. And if we could just have something like just put the version on there, You already got a package, so just go find that. Then you wouldn't need to worry about having to do any of this. You could just build the subscription object just like that.
Right, right. The other, so Evan, the question you originally asked, was it also getting at the point I was making about not knowing which previous versions exist in an index for a package?
Well, it was that, but it was also sort of, I don't know, it's kind of like a chicken and egg problem in my mind. Like if you need an operator, if you want the etcd operator or something, you just go say, I want etcd operator and give me the latest one, because you don't have any preconceived notions of some particular feature that, you know, was deprecated in a new version or something like that. And so in my mind, the only time you ever need to really specify the starting CSV is if you have, for some other reason, some out of band reason, know that you need some older version. So the discovery part, it seems really valuable to be able to inspect the graph just generally, but then I'm curious about the use cases of like intentionally picking non-latest versions if you didn't already know you needed a non-latest version. If that makes sense.
I still am like not quite getting that last statement you're making. I think like, so we always like to compare with Yum in RPM, right? I think in my mind, it's nice to be able to tell Yum, like, don't install the latest one. Like, I want you to install this specific version. And that's all I was trying to solve with the -- version flag on the operator install command line.
Yeah,
that makes sense to me. It's just, don't you need to know that you want that particular version first? And then once you know that you need that particular version, then you don't need to list out what's available. That's kind of what I mean. It's kind of,
yeah, I see what you mean. Yeah, I see what you mean. It could be like, so maybe this is a contrived example, but let's say, you know, things are following Simver really well, and I see that the latest version is V3, but I don't want that. I want the latest V2 minor version. I don't know what version that is though, so like I'm gonna have to go and list them out, and I want to do V2.100.1, right? Like that's the one I want. I don't know exactly which one that is, because there might be a 90 and an 80. I don't know exactly which those are, but I know that I don't want V3.
that was actually pretty useful. Thank you.
Okay, cool. We do have a lot of items on the agenda, and I don't want to like downplay how great this tool is. So I think it's something that we should, you know, definitely everybody should look at and use and possibly contribute to. So really great stuff there. I just want to keep moving on because we do have like 4 more agenda items, and we're coming up on the last 10 minutes. So we'll try and bust these out as quickly as we can. So Chris asked about OLM 1.0 status. I suspected that this came up because the operator SDK 1.0 was recently released.
Exactly right.
Yeah, no, great question. So right now OLM is trying to figure out like its upstream release cadence, the version strategy, and you know our support statements for the upstream version. But it isn't totally ironed out right now, and we're actively working towards it. And I know that's kind of a non-answer right now, but I don't think I can give you any more of an answer. Does anybody have, Evan, do you have anything you want to add to that?
Yeah, I would definitely, yeah, it's TBD, but I think we would want to do something very similar to what the SDK did, in that we would identify milestones and targets for 1.0, identify which legacy things we want to make sure to drop support for when we hit 1.0, and kind of go from there and see how long it will take us to get to what we want for 1.
Yeah, I just I'm sensitive to it because OCP 4.6 is coming out, I think, in October. That version is the EUS/long-term service release. So that is going to be the real first testament for our customers of going into production with workloads. And so we're going to need OLM to be treated as if it were 1.0, which I think OpenShift is agreeing to do, right? And so we just need, I think everybody likes the little warm fuzzies of having 1.0 in the version numbers, which ties into the next thing, which is basically when when OCP 4.6 comes out. So when 4.5 came out, it talked about the open operator SDK that it supported, which I didn't think it needed to, because the operator SDK is really kind of a development tool. What it really needed to do is talk about the versions of OLM, OPM, and all these other pieces, that are supported.
So I think that's an entirely different question. So our version string that you see in the OLM repo is for our upstream project. When you're talking about OpenShift and you're talking about the downstream product, that carries all of the full support statements from OpenShift for that particular version of OpenShift. So the 4.6 OLM is supported to the same degree that OCP is. The same for the OPM that's shipped with 4.6. So it's just kind of like, I would just think of it as a separate product almost, with separate support statements.
No, I get that. Maybe I don't get it. So yeah, so there's an upstream.
It effectively means, sorry, I'm just saying, it effectively means all the APIs that you're using in OpenShift, if they're enabled by default and the behaviors are enabled by default, carries the support statements of OpenShift in the entirety. So that means that like you get the whatever the version n plus whatever version support is, etc. Maybe that helps.
Right. Yeah. Right. Like I think the way I think about it is we don't ship OLM on top of OpenShift. OLM is a component of the OpenShift source. The fact that we also have an upstream release process is just like a totally separate thing. Like the upstream project is a thing you can install on top of a vanilla Kubernetes cluster. OLM in OpenShift is just part of OpenShift. So it doesn't really it doesn't have a separate version. The version of OLM that's in OpenShift 4.6 is 4.6.
Gotcha. So yeah, I get that. So it's compiled differently, and it's using the source as a base with it's a cherry-picked commits. So it's very similar to an upstream version, but not exact, right? And so okay.
And I would say that you can expect that to diverge more over time. Since this is our upstream working group, it's worth mentioning that we're actively looking at how to split out our downstream bits from the upstream repository, so that those are anything OpenShift specific will be in a separate repository built separately, and then the upstream OLM will be only have references to upstream components.
Yeah, because I think there's a lot of bleed still between the upstream and downstream, and it's not always clear where the firewall is set up. Like we just ran it with OPM. OPM is pulling the builder images from upstream accidentally instead of the downstream ones. Just building things on the fly. So it's kind of a weird scenario, but there's things like that.
Yeah, that's more a function of all of our defaults point to upstream things, and then when we're talking about downstream, those all get overridden to point to downstream things. And so, like for example, OLM when it starts up, it just detects if it's in OpenShift or not, and if it's in OpenShift, it spins up all these extra controllers and does all these extra things. So our goal is to like pull that out so that the code that detects that in the first place is just not in the upstream OLM because it's not useful upstream.
Right. I'm talking about the OPM command line tool itself, right? When you're running that outside of a cluster, right? So that actually it doesn't know necessarily that it was today. It doesn't know that it was an OpenShift supported version of itself.
Yeah, so that's definitely true. I think one of the things we do need to do as part of, so Evan was talking about us separating right now we just have one repository. Reality, there need to be two separate repositories for each of these projects, one upstream, one downstream, which is something we're actively looking at how to do right now. I think one of the things that probably one of the first things we need to do when we separate out the operator registry project is make sure that the downstream version of OPM that gets shipped points to separate things, which it wasn't doing which to me, that's kind of just a bug in the downstream release process more than anything else.
Yep.
Okay. Should we discuss the OLM OPM version sorted by OCP 4.6, or is that fairly addressed with the discussion we had regarding the 4.6 LTS support?
Yeah, so I guess so I think we're not supporting a specific version now. It's really about what commits are being sucked into OCP 4.6, right? I think that's really the question. So is there a feature list and a list of features that are supported versus not supported within that scope?
The only
or do I need to look at the branch and then try to figure out what commits are in the branch to figure out what's going to be there?
Yeah, I mean, if you're concerned about like at the commit level, what exactly is in the specific release for OpenShift 4.6, I just put a link. That is just the branch. That's the only thing that we have right now that actually explicitly separates out. The only other thing we have is the downstream OCP documentation, which is not necessarily like aimed specifically at like developers who are building on top of.
Well, so here's the issue I've got is that we want to release our products like a week after 4.6 comes out. So between now and then, we need to know what features of OLM and OCP we can depend upon, because there are a lot of gaps in there we wanted to make use of. And so that if we don't do it that way, that means we're going to be always a cycle behind.
It's a little hard to talk about developing things against a platform that hasn't been released yet. Like the features, you're going to have the features exist before you can, like in GA, before you can develop against them, right?
Yeah, but there's going to be things that are going to be released earlier than later, and you've got a development path, right? And so you've got a target, right? And so I understand that some targets change and things get pulled at the last minute, but there needs to be some kind of, kind of a guesstimate of what you think is going to be there. Or is that just not feasible? We wouldn't be expected to use any of those new features until potentially months after, or as fast as we can go, I guess, from it's released.
I mean, yeah, I think it is. I think it is a little bit difficult for us to like definitively make any statements around what is or isn't going to be available necessarily in a release before it's released. Generally, I think like in the context of the OpenShift release process, what we attempt to do is we attempt to stabilize the release over the last few weeks before the release actually happens.
Right.
So that's when, like, I think we're sort of at that point now, right now in OpenShift 4.6, where for the most part, the only things that are going into that branch are, if there are bugs, we fix those. Otherwise, there aren't any like major features that are still like in progress for 4.6.
So for 4.6 right now, how would I know what features are in there other than looking at commits?
Yeah, so that's it. We don't really have like a separate set of release notes for downstream before the release happens.
So have you guys built a tool for yourselves to kind of turn all the commits into English?
So, yeah. So
well, yeah. Go ahead, Alex.
Nick, you can capture this thing, and then I think we just need to move on because we're coming up at the end of the hour.
Yeah, for the upstream downstream split, I think somebody on the OLM team, Ben Lenny, had described a better way of curating release notes when we cut release and automating it. Right now, at least the OLM repo, we do have something that aggregates semantic commit messages into features and also across PRs and make that a little bit nicer. I don't think that runs against OPM or the operator registry repo right now, but it does run against OLM. So, and we do keep a running change log as well. Hopefully it'll be more intelligible once we get the upstream downstream release stuff set up. Does that help at all?
Yeah, a little bit. I mean, so I guess you're just confirming what I knew. I was hoping that you had something a little bit more user-friendly that we could use to try to figure out what's coming, right? Because right now we tend to get surprised. I mean, we've seen PowerPoints from Daniel Messer and those guys saying, hey, these are the major kind of focus things. We haven't seen that for a while. And so we're not exactly sure what to expect until we see it. And then maybe you're in the same boat, but I'm sure there are things that you've committed to internally, which you just haven't wanted to divulge.
No, I think that's actually it's a good topic to bring up for this group. We should we need to make sure that planning happens in the open and happens publicly, and that I know the SDK team uses GitHub milestones. That might be something we want to do, but I also know that I think the Jira project that we have been using to track is also public. So something in there, it would be great if we could get our planning more open and public as well. I know we've tried to do more of the discussion in the open, and we have the Slack channel now, which should help. But milestones and target releases and things like that, that's still something we need to improve.
Yeah, and just to, you know, we can make it like a to-do item to actually discuss how we want to like capture some of this information. I do know we are talking a lot about like the OpenShift specific 4.6 release branch, which is hard to get away from right now with OLM, just because we don't have that upstream downstream split. I do want to just make sure everybody remembers that like we can speak a bit about like the OpenShift specific side of OLM, because that's really all that exists with the mono repo we have right now. But in general, if we could try and focus more on like OLM as an upstream project more so than being tied into a specific version of OpenShift, that'd be great.
Yeah, I get it. I just our customers want the something that works. So
Yeah,
I brought it up. Yep.
Yeah, and you know, like Evan was saying, we are making more effort to have these conversations in the open. I think a follow-up is just making sure we can go and make sure that our we can double check to see if that Jira is all viewable publicly, and I'll just have to do on the list.
Yeah, if you could at least put in maybe in this agenda note here, just maybe what the procedure you would expect someone like me to use. Right, so that's the to-do. It's like, how would I do it today? And then maybe like what you plan on doing tomorrow, or the to-do tomorrow. That'd be great.
Great. Kevin, do you have something you want to say?
Yeah, I just wanted to make one other quick comment around all that the stuff we were just discussing around planning. I think that all that stuff is super accurate and super valid, and it's something we should be, as a group in the upstream project, attempting to be better at. I do want to keep in mind though that there is a difference between stuff getting shipped into the upstream project versus actually released in the downstream version of OpenShift, because it's entirely possible that we do a bunch of work, you know, we make a feature happen in the context of when our planning was supposed to, and then some other downstream thing prevents that feature from actually making it into the downstream project. So if what we're actually looking for is how do I know when features will make it into OpenShift, that I think that is going to be a slightly separate discussion and a slightly separate conversation, and we should just be aware of that and maybe try to figure out some ways to deal with those problems.
Yeah, I want both. I want
Sure.
both answers. Yep.
Yeah, I mean, if I could have both, that would be helpful for me too. But
Okay, so we are at the top of the hour. I can push on if people want to stick around, but I don't want to waste anybody's time. Maybe we should just move these two items to the next meeting. That way, if somebody has to leave, we can, you know, they can actually see the discussion then. Yeah, let's do. Is everybody okay with that?
seems reasonable.
Okay, cool. So we'll do that. I do want to do one quick shout out. There is an enhancement that I've been working on that I just want to like make sure that everybody in this group knows about. It regards allowing operators to communicate with OLM, specifically supporting the ability to tell, like if an operator is running a critical process, such as migrating a database, for example, or something similar, our goal is to enable that operator to tell OLM, like, hey, don't upgrade me right now, because if you kill me, I might lose, I might get into an unrecoverable state effectively because of some upgrade or migration that I'm performing. And it'd be great if everybody could just review that. It's pull request number 23 against the operating framework enhancement. And it'd be great just to have community feedback, because my goal is to have this merged fairly soon. And it seems like a feature that many people might want to take advantage of. Being able to tell OLM not to kill the pod is pretty useful. So please take a look at that. And I'm going to conclude the meeting now. Thank you for coming.